PCA I found is a really great way of exploring the relationship between columns in your data set. So today I'm going to be looking at US home target return drivers with component analysis, and it will make more sense as we dive into it. But the overview of what we'll do in this video is get pricing data for homes and then calculate the returns for those homes and then run those return calculations through principal component analysis across different time periods and look at the relationship of the returns and what factors are driving those returns across those different time periods. So I'm going to be using the FRED API. This is the St. Louis Federal Reserve API. Excellent place to get econometric data. Um, they have tons of data there. It's really worth the effort to go and get in your own key, and it's pretty simple to grab. You just get to the URL, you want your endpoint, which is the observations of series data, and then pass through your key. You put all that into a parameter list. When you request it, it'll come back in a JSON. Just grab the observations. And I like to drop the real-time start and real-time end because I'm really only interested in the observation date. I set the observation date to be date time, make sure that the value is numeric, and then just set the index to date. Rename the columns so that the value is the home price so I know what I'm looking at. Drop any NA, and this is what you'll get. You'll sort of just get a series with your value of home prices there and a date. So the home price here, this is not saying it was $59. This is like an index price. So this is something that's been scaled and adjusted based on, um, you know, consumer price indexes at the time, et cetera, et cetera. But the idea should still be the same. It doesn't really matter what the number is. It's really like the relationship as the number progresses across time that we're interested in. When we plot it, it looks like this. So it starts back before 1980, and it just slowly climbs up and up and up. I'm guessing this is like around 2008, right here, right before 2010. You can see we have that 2008 crash here, home market crash. It doesn't start building back up until 2020. You don't even see the home prices drop in 2020. In fact, it just like kind of, there's like a elbow point where things even start exploding even more. So cool. It's got to come back down at some point, but as you can see, even if you bought right before the crash of 2008, if you would have just held on to it 10 years, you'd be you'd be you'd be even doing better, right? So cool. So the idea here is, if that is the case, is there a way we can predict target returns as time marches forward? Um, and we do that by calculating the lag and the targets. So what this looks like here in our data frame is we're setting our lags to calculate the percent change of the lag into this, and we make its own column. So it'll be like return lag 1 month equals the home price of that percent change of that value here, right? And then the targets is shifting those calculations back to the row where we would originally calculated from. So like here for this first row, our 1 month return is 0.015, but to avoid data leak, we need to shift everything back to its original target date. So we would say on 1975, what would be our 1 month target return? What's this? Our 6 month target return would be that, et cetera, marching forward. So our returns are really, why is this 7 month not an index? 1, 6, 12, 24, 1. 1, 6, 12, 24, blah, blah, blah. Okay, cool. So now we just have a data frame with just our returns in it, and that's fine because when we perform the component analysis on it, we don't we don't really need the home price or even the return price. We're just interested on what factors in the target, like for instance, we want to see the relationship between 1 month, 6 month, 12 month, and what factors contribute to the variances between these different target points. And so we initialize our component analysis. We're going to use 3. That's what I've always seen in every tutorial with component analysis, but most of the time you can just do 2. It's really up to you if you want to just capture as much variance as you possibly can. And when you look at this instance, almost 100% of the variance between these columns is captured in the first factor, right? When we consider the other 2 factors, it takes it to 100%. So there's only 3 factors that are contributing to all the variances between these different variables, or these different columns here, or these different target points. We then, make our target returns or our factor returns and for each different factor on the dates. And then we change that to be our exposure. So now we have our exposure for target 1, 6, 12, 24, 48, and the exposure for each of these factors in a little data frame here. When we go to plot it, this is what we get. So you can see that factor 2 has pretty solid, like as you march forward on up, we'll be going 1, 6, 12, 24, your exposure to factor 2 just continues to increase. But then at some point you hit 48 and this factor disappears and you start moving along the first factor variance. So there seems to be your target returns are really captured in this exposure 2, but then there's something that shifts where if you hold on to the price of a home, for example, if you hold on to it long enough, that will then shift to this other factor here. And you can see target 120 is almost, I think it's negatively exposed to the second factor. And really it's just capturing in the first factor. So this is something I would use. This is an example of something I would use to understand the relationship of what factors are exposed to the different time interval returns, and then start building off questions from this. So my main question is, what is the change here? How come when you go from 24 to 48, your exposure to this second factor completely goes away? I would kind of assume that you would just keep seeing, like 48 would be somewhere up here where it's really exposed to factor 2 and it's also continuing to move along factor 1. So something happened, and it could be this dip here, right? It could be that this is the variance that when you hit this point, you eventually will hit a bear market. And so if you hold on to a home long enough, you will hit a bear market and you will just see it plummet. But 48, I mean, that's only 2 years, right? 48 months, it's only a 2-year span. So, even back here, if you bought in the 80s, like 2 years, I guess you see a little dip there, but 2 years and 85 to 87, like that's like right here, right? So, I don't think it's a bear market that happens that's creating that total reversal of exposure and the factors. It seems like they all move along factor 1, but at some point you just hit a point where you just start going negative on factor 2, which is pretty interesting to see. So yeah, PCA, it's got its pros and its cons, but the pros is definitely to show you what is the relationship between these, whatever your columns that you want to look at for. Okay, I've rambled enough, but if you're interested, you can head over here. You can download this notebook in the description, head over here to this link and support me. I would really appreciate it, but there's no pressure, of course. Um, yeah, I'll see you in the next video, and yes, safe investing out there. Bye.